This is Unit 910, looking for relationships. We're working away on box E here. And what we want to be able to do by the end of this lesson is we want to be able to draw a line or curve of best fit to a set of data and use it to make predictions. Most of the work that you're going to do in box E involves drawing scatter plots. We've already looked at how to set up a scatter plot. So this lesson is mainly going to focus on drawing the line or curve of best fit and using it to make predictions. So, just to recap some of the stuff that we've already talked about in previous lessons. Why do we use scatter plots? We use scatter plots to look for relationships between the variables in a set of data. If the points in the scatter plot show a trend, there is a relationship between the two variables. So let's look at an example here. An Olympic village has to be built at the site of each Olympic Games for the athletes to stay in. The village must be big enough to hold all of the athletes. Organizers collected the data below. So they looked at the location of various Olympic Games here in various years, starting in 1964, every 4 years up until the Atlanta Games in 1996, and they looked at how many athletes attended each Games. And they took this data and they plotted it in a graph. A nice little scatter plot here. They said, okay, the number of athletes is going to depend on the year, so year is my independent variable, number of athletes is my dependent variable up along the side. And then they're sort of asking themselves a few questions about this graph here. I've got the questions on the next page here, so I'll have to jump over. Is there a trend in the graph? Well, I think it's pretty obvious from looking at it that yes, there is a trend. How would you describe this trend? Well, we would say it's definitely an upward trend. Okay, because as year increases, the number of athletes is increasing. And then we've got to think about whether we can draw a line or a curve of best fit to this data. Is it better fit by a straight line or by a curve? Well, I think we can probably get away with a straight line. Okay, we can go kind of like this. And what we see here when we draw it is we're drawing a nice straight line that follows the trend, and we try to get about the same number of points above it as we do below it. Okay, so right now I've got 1, 2, 3 points above, 4, 5 points above, and only 3 below. So maybe this would be a little bit better if, you know, this end was up a little bit like this. Then I've got, maybe that's a little bit better, kind of like that. Here I've got 1, 2 above, 1, 2, 3 below now. Okay, and these other ones, oh, I guess 3 above and 3 below. So that's a pretty good line of fit, about the same number above as below. Okay, so what we can add to our answer over here, is there a trend in the data? We can say that yes, there's an upward trend. It is linear. Okay, describe the relationship in the data and draw a line of best fit. We've already done our line of best fit there, but we can describe this by saying as the year increases, the number of athletes increases. And we've got our line of best fit already. Now, this says that data points that do not follow the trend are called outliers. Identify any outliers in this data. So are there any points that seem particularly far away from our line of best fit? Well, I think we could look at this one and this one. These guys seem to be significantly down below our entire trend here. This one and this one seem about the same distance above and below, and then the line pretty much passes through all of these other ones. So these are the only ones that are really, really far away. Okay, so what do those 2 points represent? Well, those represent the years 1980 and 1984, the Olympic Games in Moscow and Los Angeles. So, data points that don't follow the trend are called outliers. Identify any outliers. Yeah. So we can say 1980, and in brackets, Moscow, 1984, Los Angeles. Okay. Turns out there's actually an explanation for why these two don't fit the trend. Okay. In 1979, the Soviet Union, which doesn't exist anymore but did at the time, invaded Afghanistan, and in protest, a number of Western European and North American countries decided that they were going to boycott the Olympic Games, i.e. not go to the Olympic Games that were held in the capital of the Soviet Union of Moscow. So there were fewer athletes than normal going to these games. You can see that's why it's well below that line. And then 4 years later, the games were held in the United States in Los Angeles, so the Soviet Union and a number of its allies decided that they were going to boycott those games as well in retaliation. So again, 4 years later, there's still fewer athletes. And then 4 years after that, everybody kind of came back to their senses, and everything sort of resumed along the previous trend. Okay, the 2008 Olympics were held in Beijing. Based on this data, how many athletes would you expect to participate? Is this interpolation or extrapolation? Well, if we're going to figure this out, we've got to find 2008 on our year graph. So let's see. 2000 is here, 2010 is there, so that's each box represents 2, so 2, 4, 6. 2008 would be right here. So we go up to here, and then we go across to our number of athletes line. And this is just sort of a rough approximation, but it looks like we're about halfway in between 12,000 and 14,000. So that's going to be about 13,000 people, or 13,000 athletes. So how many would we expect? 13,000, approximately. Okay, we don't know exactly how many. This is just sort of a rough estimate. Now, is this interpolation or extrapolation? Well, remember the difference between interpolation and extrapolation was whether we were inside all of the data points or we were beyond all of the data points. Those red lines that we've drawn there are well outside the data points that we had collected, those blue little boxes there. So I think we can say that this is extrapolation. And I should spell extrapolation correctly. Extrapolation. And that is it for box E.